Example 5, write each function as an expression involving functions of theta. Okay, I know you've had homework questions like this. You'll get cosine 30 degrees plus theta, and they want the 30 column. They don't want the 30 degrees anymore. They just want a theta in the answer. Okay. So again, you want to notice the pattern. This is a cosine sum, and cosine sum formula says cosine of the first, cosine of the second, minus sine of the first, sine of the second. Formula sheet, make sure that's right. Cosine, cosine, minus sine, sine. It's not that hard to memorize. I'm not going to force you to memorize it. It's not really that hard to memorize. Okay? So cosine 30, just straight from the chart, cosine 30 is square root of 3 over 2. So that's square root of 3 over 2 times cosine theta minus, and then sine 30, straight from the chart, is 1/2 sine theta. And that's it. That's all you can do. Okay, we're writing it as a function of theta. That's it. That's the answer. So then we look at part B, tangent 45 degrees minus theta. Again, find the formula. This is a tangent difference, a tangent of a minus. And so the tangent minus formula says tangent of the first one minus tangent of the second one all over 1 plus tangent of the first one times tangent of the second one. So it's just pattern recognition. You find the proper pattern and plug the things in where they go. Tangent 45, we should know how to do this. Tangent 45 is what? 1, right? Square root of 2 over 2 divided by itself is 1. So that's going to be a 1 and a 1 right there. Okay? So we are looking at 1 minus tangent theta over 1 plus 1 tangent theta, or just tangent theta. And that's all we can do right there. Give me those all day. Okay? I would love to do a worksheet full of those kind of problems because there's not a whole lot to it. Just find the pattern and do what it says. So sine 180 plus theta. Again, your pattern says it's a sine sum. Sine sum. And so eventually maybe you have this memorized, but that's sine 180. What is the sine sum? Sine cosine plus cosine sine. Straight from the formula sheet, straight from the formulas. That pattern for a sine sum is sine cosine plus cosine sine. And so we've got sine 180 and cosine 180 to evaluate. I find the students aren't nearly good enough at their quadrantal angles. And anytime you have a 180, anytime you have a quadrantal angle, I'm looking at the circle. I'm not really looking at the chart anymore. I'm looking at the circle. 180 degrees puts me over here at this point, -1, 0. And so you ought to be able, everybody in here ought to be able to tell me what sine 180 is. What's sine 180? 0, right? It's the y coordinate. And what's cosine 180? -1. Cosine 180 is -1. And so I'm looking at 0 cosine theta plus -1 sine theta. This is going to fall out. 0 times cosine theta is going to be 0. But it's 0 plus -1 sine theta, and that simplifies to just negative. So, example 6, suppose A and B are angles in standard position with sine A equal 4/5, pi over 2 is less than A is less than pi, and cosine B is -5/13, so pi is less than B is less than 3 pi over 2. Find the following sine A. Okay, now, what I find a lot of students do is when they see this, they don't quite understand what that means, and so they skip over it and don't even look at it. But that's going to be a huge mistake. You've got to really think hard about what these two things right here mean, because it is important. If you think about your xy axis and your quadrants, we know the quadrantal angles in radians are 0, pi over 2, pi, and 3 pi over 2. And so when we're talking about pi over 2 is less than a is less than pi, basically what we're talking about is angle A is in between pi over 2 and pi somewhere. Okay? So what that's trying to tell us is angle A is in quadrant 2. When you read that, you should read angle A is in quadrant 2. That's going to help out a lot. Okay? And so then when you see the other one, when you see this one, pi is less than b is less than 3 pi over 2, that's telling you that b is somewhere in here. B is in between pi and 3 pi over 2. Or, in other words, you've got some kind of angle in there. You've got some kind of angle that's in the third quadrant. So it doesn't come right out and tell you quadrant 2 and quadrant 3, but it kind of does. It's telling you angle A is in quadrant 2, angle B is in quadrant 3. Okay, so we start with that, and we know that. But then we're trying to find sine A plus B. Sine A plus B. I see a pattern. It's a sine sum pattern. And so you look up your sine sum pattern and see that it's sine A cosine B plus cosine A sine B. So we did a problem just like this the other day. This is an important question. It's going to be on a quiz. So make a note of that. You know it's going to come up. I see 4 holes to fill in. Sine A, cosine B, cosine A, sine B. And if you'll notice, they gave us some of those holes. Sine A was given to us in the problem, 4/5. Cosine B was given to us in the problem, negative 5/13. Now, we do not have the other two things. You can't just fill those in because you don't know what else to do. What we're going to do is draw a picture. Okay? I'm going to draw a picture of angle A. Now, remember, we knew angle A was in quadrant 2. So what I'm going to do is I'm going to draw a picture of angle A in quadrant 2. They gave me the sine ratio, which is important. We know the sine ratio is y over r. That's way back from chapter 5. But if the sine ratio is y over r, and that's 4/5, we know two sides of a triangle. And using Pythagorean's theorem, we ought to be able to find this missing side as a 3. Okay? Or we think about quadrant 2, and we know x numbers are negative in quadrant 2, so I'm going to just call that negative 3. Okay? I know that's going to be negative 3. If you don't believe me, then you do x squared plus 4 squared equals 5 squared, and do your Pythagorean theorem. But you're going to come up with x equals plus or minus 3, and then you would know, oh yeah, second quadrant x number is going to be negative. Okay? So the whole point is, I still need to know cosine A. And I can tell pretty much anything I want to tell from this picture. Cosine A, I know that ratio is x over r, that's negative 3/5. And so cosine A, negative 3/5, I've got that whole filled in. I've still got one more, but that's talking about B. And so I'm going to draw a picture of B. Angle B, we remember we noticed B was in the third quadrant. So let's draw a picture of angle B in that third quadrant. They give you the cosine ratio is negative 5/13. So since cosine is x over r, we've got those two sides of this triangle. Again, I can do Pythagorean to figure out the missing side. I know that's going to be negative 12. You just know there's a 5, 12, 13. Sometimes you memorize these patterns and you just know what that's going to be. If you didn't know that, you'd say y squared plus negative 5 squared equals 13 squared. And you'd solve that out and we get y equals plus or minus 12. And you know, oh, third quadrant, the y numbers are going to be negative. And so the whole point of this was we need to know that sine B. And sine B is the ratio of y over r. And so we know sine B is negative 12/13. We had to fill in those 4 holes, and once we got those 4 holes, all we have to do is simplify our fractions. Okay, so 4/5 times negative 5/13, that's negative 20 over 65. And negative 3/5 times negative 12/13, so it's positive 36/65. You're going to add negative 20/65 plus 36/65, you get 16/65. So remember what we're trying to find, sine A plus B. Sine A plus B equals 16/65. So understand what A plus B means. A plus B is an angle. And so it's maybe kind of difficult to think about, but you got this representing angle A, something in the second quadrant, and then you have a bigger angle, something representing a third quadrant angle. If you added those two values together, okay, sine of that added angle, sine of that angle sum is 16/60. Example 6, 6b, we've got tangent A plus B, and that should, that forces you to look at your formula sheet. I've got tangent sum, and that tangent sum formula says tangent of the first one plus tangent of the second one over 1 minus tangent of the first one times tangent of the second one. There's my formula. So then I've got 4 holes to fill in. So this is very similar to part A. I'm just using a different identity. I'm using the tangent identity instead of the sine identity. But the problem didn't seem to give you any of that information. It didn't give you any of those tangent values. But if you look back at your picture, it's pretty easy to figure out from your picture. When we look at angle A and this triangle right here, all we have to do is find tangent A, and I can do that from this picture because I know tangent A is y over x. And so just look at this picture and look at y over x, 4 over negative 3. That's tangent A. Opposite over adjacent, if you will. But tangent A is negative 4/3. And so in your formula, you should be able to fill out tangent A as negative 4/3 in that expression. And so what else do we need? Tangent B. Look at your picture. Okay, look at your picture. And here's angle B, or here's your triangle. And so if we want tangent B, again, that's y over x. That's going to be negative 12/5 or positive 12/5 if we do y over x. Y over x, or opposite over adjacent. So tangent B is going to be 12/5. I've got the 4 holes filled in. I just need to do some algebra to clean this up. And maybe that's the hard part. I don't know. But look what we have. We have negative 4/3 plus 12/5 over 1 plus 48 over 15. Clean up that fraction. And on the bottom, you can multiply it 4/3 times 12/5. And as always, when we add fractions, we want a common denominator. So let's get a common denominator. So over here, I'm going to multiply by 5 over 5, and here I'm going to multiply by 3 over 3. So that I'm looking at negative 20/15 plus 36/15. And on the bottom, 1 plus 48 over 15, let's just call this 15 over 15. I'd have 15/15 plus 48/15 is 63/15. And so cleaning up the fractions, negative 20 plus 36 is 16. I have 16/15 over 63/15. And at some point, hopefully you notice that those 15s are just going to cancel out. Okay? I know the 15s are going to cancel out, and hopefully you do too, but if you don't remember that, you're dividing fractions, and so let's multiply by the reciprocal. That makes it a little bit more obvious why the 15s cancel out, but we're going to get 16 over 63. So we wanted to know tangent A plus B. Tangent A plus B equals 16 over 63. So then the last question should be the easiest question. I find students struggle with it a little bit because it's not quite obvious what you're going to do. But they want to know the quadrants of A plus B. Not the quadrant of angle A, not the quadrant of angle B, but the quadrant of what you'd have if you added those two angles together. What quadrant would we be if we added those two angles together? Okay. Well, let's recall what we got in part A. Sine of that angle sum was 16/65. So we had sine of A plus B equaled 16/65. And then what we just found in part B of our question was tangent a plus b equals 16/63. Okay. What's noteworthy is that both of those values are positive. Sine of that angle sum is positive, and tangent of that angle sum is positive. So if you look at where sine is positive, we know sine is positive in the first or second quadrant. And if you look at where tangent is positive in the first and third quadrants. And so you put those two things together. We know that sine is positive and tangent is positive. Well, there's only one quadrant where that can both be true. Both of those things are true in the first quadrant. And so we know that sine and tangent are both positive in the first quadrant. That's it. Quadrant 1. Example x2, verify this equation is an identity. Well, one of the hints that we always do is start on the more complicated side. I think it's pretty obvious that the left side is the more complicated side. And so you look at that, it says sine of a sum. I see a sine sum. Sine sum. And so let's use our identity for a sine sum. Okay? I'm going to take this sine sum and I'm going to just convert it into the sine plus. Sine sum was sine, cosine, cosine, sine. And so let's take this, and it's going to be sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. Sorry, what? No, because I haven't even looked at this yet. I haven't even looked at that yet. All I'm doing is the sine sum on that first one. Okay? So the only angle I'm looking at right now is this pi over 6. Okay? So we can simplify that. I know sine pi over 6 is 1/2. And cosine pi over 6 is square root of 3 over 2 from the chart. And so that would be 1/2 cosine theta plus square root of 3 over 2 sine theta. But basically, we want to do the exact same thing with that cosine. Okay? When we look over here, we see a cosine sum. And so we would have a second identity for this cosine sum. Okay? Cosine sum says cosine, cosine minus sine, sine. And so we would have cosine of the first one, cosine of the second one, minus sine of the first one, sine of the second one. Cosine, cosine minus sine, sine. That's the pattern. Look at your formulas. Have your formulas handy. I know you don't have them memorized, and that's okay. But have them handy so where you can look at them at least. And so we look at the chart now. Cosine pi over 3. Cosine pi over 3 is 1/2. And sine pi over 3 is square root of 3 over 2. So if we plug all that in, we would have plus 1/2 cosine theta minus square root of 3 over 2 sine theta. Now this is the left side. This is the left side of my equation. And you always kind of keep an eye on the other side. We want that to clean up and equal the right side, which is cosine theta. And so look what happens. It was a really complicated looking mess, but I see 1/2 cosine theta plus 1/2 cosine theta is going to equal 1 cosine theta. But then I also see square root of 3 over 2 sine theta minus square root of 3 over 2 sine theta. Those don't even cancel each other out. So that's gone. All I have left there is cosine theta, and that's exactly what I wanted, right? I wanted cosine theta equals cosine theta. Okay? So at this point, my left side equals my right side, and I'm finished.